Problem 5, another mathematical induction problem. I want to prove that 1 over n plus 5 is larger than 1 over 2n so long as n is greater than 5. Now, instead of showing it here, it'll be enough to show that 2n is greater than n plus 5. These are obviously positive numbers when n is greater than 5. So I make a positive number smaller by making the denominator larger. So if this denominator is larger than this denominator, then this entire number is smaller than this entire number. So show that 2n is greater than n plus 5 for n greater than 5. Step number 1, I show that it works initially. If n is equal to 6, that's my first integer greater than 5, then 2 times 6 is equal to 12. Meanwhile, 6 plus 5 is equal to 11. And since 12 is greater than 11, 2n is greater than n plus 5 when n is 6. I put a check mark to show that this fits this. Second, I assume that 2 times k is greater than k plus 5 for some k greater than 5, and I then show that 2 times k plus 1 is greater than, and I'll put it way down here, k plus 1 plus 5. It's probably simplest to expand both. Here I have 2k plus 2, and that is going to be equal. Here I have k plus 6, and that's going to equal. Now, at some point I need to use step 2. I'll do it now. The 2k that I see on the left, I happen to have here. If 2k is greater than 5, then 2k plus 2 is greater than k plus 5 plus 2. So I've replaced my 2k with a k plus 5. This is equal to k plus 7, which is greater than k plus 6. Sorry. This is equal to k plus 7, which is greater than k plus 6. Look down the line at your signs. So long as they are all either equal, greater than or equal, or greater than, and at least one of them is greater than, then this will be greater than this. Now that's what I was trying to show, so I'll make some mark at the end. Let's put in QED. I have shown what I attempted to show.